Start now. We have around 40 plus participants. Okay, so good afternoon, everyone, and have a and very warm welcome to today's webinar on managed EV charging and demand flexibility. I am delighted to have you all join us for this important conversation. Uh, this session is part of our ongoing webinar series on demand flexibility, where we aim to explore how different end users and enabling technologies can play a pivotal role in shaping a more responsive, effective, and sustainable electricity system. And our first two webinar held on 12th March and 1st April focused on peak saving through demand shifting in public water supply and also flexible. And second one was on flexible energy services for meeting cooling demand in buildings. So both the sessions sparked valuable discussions among distribution licensee, end users, and technology providers. And today's uh, discussion will be focused on mainly on growing electric vehicle ecosystem and how managed EV charging can become a key tool for demand flexibility. So with the rapid adoption of EV ranging from bus to two-wheelers, there is a timely opportunity to integrate charging needs with great flexibility. So over the next 80, 90 minutes, we'll be discussing a short context setting presentation and followed by technology providers presentation by Kazam and a curated discussion among our panelists. And finally, we'll take your questions in Q&A. Last 10, 15 minutes, we'll take your questions. So I'll take this opportunity to introduce our panelist. So we have Mr. Akshay Ingalahalli, project manager from Kazam. He has over 8 years of experience in end-to-end project development, driving innovation across industries such as electric vehicle, fleet management, and home automation. And then we have Mr. Pradeep Aggarwal, general manager from BRPL. He has over 20 years of experience in utility sector, specializing in renewable energy and electric vehicles. He holds PGM in strategic and finance from Indian Institute of Management, Lucknow. And then we have Mr. Arjun Gupta, manager power sector from RMI. So he has over a decade of professional experience in solar, wind, and battery storage startups across four continents. And then we have Mr. Manoj Gupta, CEO-Ecofuel EV charging technologies from JBM Group. He has over 3 decades of experience, expert in energy transition and e-transport. At GBM, he pioneered commercially viable strategies in EV charging technologies. Then we have Mr. Rahul Lamba, co-founder of the energy company. He has nearly 8 years of experience in technical and advisory and management consultancy roles across emerging market, particularly in India. He earned particularly in India, and now we are delighted to have Mr. Dr. Mahesh Patinkar, Managing Director, MPN Systems, as our moderator. So he has over 32 years of experience in energy environmental projects, spanning energy, water, transport, rural development, technology, and business innovation sectors. So now we'll move forward, and we hope today's discussion will bring actionable insight from distribution companies and technology providers and policymakers as we look to design and scale DF initiative across India. So yeah, thank you so much all for joining us again. So just a second, I'll just share my screen and start our first presentation. I'll just briefly talk about demand flexibility and briefly about managed EV charging. And our panel discussion will give more insight into uh, the the pro, the actual implementation of managed EV charging. So this is the flow of our presentation. I'll start with introduction to demand flexibility and opportunities in it, and then uh, briefly talk about Maharashtra's demand flexibility regulation and what are the possible opportunities in managed EV charging and demand flexibility. In the past, our distribution network was mainly following the load, which basically means that your generating stations are uh, modulating their generation according to the load profile. Here we are mainly considering mainly dependent on the generating station to follow the load. But now, as we have higher renewable energy integration, which is a must-run power plant and which is mainly dependent on weather parameter, which can't modulate based on the load requirement. So, uh, so now we need a demand which can be modulated, and we need different kind of interventions, which means you can use the demand response and also to modulate your load, you also need demand flexibility. So demand flexibility is basically you are not changing your load requirement, but you are shifting your load from a peak hours mainly to non-peak hours, or it can be a non-solar hours to solar hours, basically to meet your generating capacity and utilizing your generators more. So this demand flexibility will mainly address three key issues in overall distribution network. One is by doing demand flexibility, you will utilize renewable energy more, and you will have more renewable energy into the grid as well. So by reducing your demand in of non-solar hours, you are basically increasing the renewable energy flux into the system. And meanwhile, you are also providing incentive to consumers. So that means that you are distribution licensee uh, will give benefit to end use to consumers as well, which will eventually reduces the consumer bill. And you are reducing your peak requirement, which means you are reducing your power purchase cost, and uh, and eventually you are passing on that benefit to consumers as well. So demand flexibility will be very crucial for your grid stability as well. So here we'll be talking about what are the uh, requirement, and when you need demand variation is much higher, then you need a demand which can be modulated so that your spikes can be reduced. And second is when you have higher amount of renewable energy generation, that will also cater to uh, a spike in net load demand, which means you need to fill that valley with the more demand. And the third point is when you have higher annual growth in the peak demand, which means you will be having a lot more demand in future years, and which will disrupt your overall load pattern as well. And when you also have and it also depends on when you have the seasonal variation, a lot of seasonal variation into the system. And the fourth point is, as our webinar is focused on that, increasing EV demand, which means you will be having uh, a load which is varying, and as well as your load is also varying on a location basis as well, because your EV load is not stationary. You will be charging it in different locations, which means that you need a system which is robust to have support that additional charging requirement. And demand flexibility readiness means if you have a regulation which supports DSM, DSM or DF programs, that means you will be able to provide incentives to consumers. And to fulfill the resource adequacy guidelines, you need demand flexibility, which will be the component of resource adequacy as well. And so for modulating the demand, you need a smart meter installations, which will be the base for your flexible load. And battery storage installation will be a add-on, which will help utilities to shift the demand easily. So this is the one of its kind regulation so far, which talks about MERC's regulation, titled as Demand Flexibility and Demand Side Management, Implementation Framework, Cost Effectiveness Assessment and Evaluation Measurement and Verification Regulation. So here in this regulation, there is mainly three parts. So first part is talking about the overall demand flexibility framework, and how program can be structured, and what are the guidelines to fulfill or prepare the demand flexibility programs. And part B talks about cost effectiveness test, which means how your program will be affecting the distribution licensees finance, and as well as you are also looking after consumers interest and their viability for opting for this program. And part C talks about how this program can be measured and verified. And the interesting point in this regulation is distribution regulator have, which is basically starting from 1.5% to 3.5%, which is mainly uh, uh, linked with your previous year's peak demand. So for the first year, distribution licensee has to identify the flexible demand into the network, which is 1.5% of their previous year's peak demand, which will mandate distribution licensee uh, to opt for and opt for this DF programs and fulfill this regulation. And in addition to this, there is a incentive and penalty mechanism linked with it, which is 20 lakh per megawatt for each target. If the target exceeds, then there is incentive mechanisms for of 20 lakh per megawatt, and similarly the penalty mechanism. And in the cost effectiveness test, as I mentioned, it includes the impact, process, and market effectiveness part of it. So it will cover overall spectrum of how the program is effective in the on ground as well. And this we factors as well as aggregators. So these are the interventions which is easy to adopt, or it can be start with distribution licensing can be start with this initial programs. So first is demand flexibility in public water pumping, which means you are utilizing your public water pumps to manage as per your peak demand. You will be modulating your public water pumps to uh, and also and also utilizing your reservoirs to not affect your overall supply of water. And in the cold storage program, you can reduce or increase your overall temperature of the cold storage to reduce the consumption in peak demand and increase your consumption in off-peak demand. And I'll be talking about more for this managed EV charging stations in the next slide. So for the heat pump, you are basically by introducing heat pump, you are uh, reporting your heat water requirement through a centralized heat pump system, which will further supply the heated water to individual household. And this coupled with water storage will help to reduce or shift the uh, water heating requirement to non-peak hours based on the storage capacity available. And so thermal energy storage coupled with your HVAC system will provide a flexibility to shift your HVAC load to off-peak hours and using that storage uh, in the peak hours. So I'll briefly talk about what we mean by managed EV charging station. So here there are five opportunities which we can think of. First is time of use charging, which is basically your charging price is linked with your uh, charging price is dynamic, so that your charging requirement can be modulated based on the uh, dynamic tariff, which will eventually shift your charging load to off-peak hours. Mm. And managed EV chargers can be used to flatten out the load curve as well, so that you won't have a charging spike in certain time slots. Managed EV charging can be used to maximize your renewable energy generation by shifting your charging requirement into solar hours or RE hours. So through the inbuilt battery in the uh, electric vehicle electric vehicles, you are basically shifting your peak load to off-peak load by utilizing your in-vehicle battery, and you can supply it to grid and also charge from the grid simultaneously when as and when required. So it is basically a bidirectional charging where you usually plug in your vehicle for a longer period of time. So it will absorb the peak and off-peak requirement of the distribution license. So briefly talking about one of the case studies in managed electric bus depot. So in one of the so in the most of the e-bus procurement is done through GCC contracts, which is basically on per kilometer revenue basis. So basically to reduce your operational cost will be your first priority for any kind of e-fleet operators. So to reduce the operational cost, you need to charge your vehicle uh, in uh, in the period where you have the lowest tariff. So that is how the uh, operational cost can be reduced. So in one of the case study, we have seen that bus operators have shifted their load to uh, TODRs, where you will be getting the more incentive. So which will eventually has reduced the operating cost around 15 lakh for a month. So, and I guess Kazam will be talking about this in more detail in our next presentation. So, yeah, I'll pause here and I'll ask Akshay to present this his case study.
Thank you. Thank I'll just share my screen. Let me know if you can see it. So what you can see on the screen is basically a digital depot. So what we have done across multiple different depots across different OEMs and operators is we have digitized their entire depot by onboarding and installing a lot of smart meters, which is giving us data all the way from the grid to the chargers. So what I think was being mentioned is how can we basically shift the load of the buses uh, over a period of time. But there is a problem with this. While we are solving the use case for the utility, which is they can better shed the energy and they can better understand the demand that is needed by these micro depots, it has to be incentivized to the operator. Uh, in the incentivization can happen via electricity savings. Also, we have to keep in mind that there is a regular penalization that can happen if the schedules of these buses are not met as per what is the tender that is being defined. So now, if we have on one side where we want to make sure the schedules are maintained and there is an electricity saving that is happening for the operators. On the other hand, we are also want to make a win-win situation for the utility so that they can better shed or shift the load to a uh, lesser loaded zone. So in that is only possible if we have the depots that is completely digitized in terms of smart meters. And in one of the use cases, if I want to talk about specific to Telangana, where government is already incentivizing energy between 10 p.m. to 6 a.m. by giving 1.5, like 4.5 rupees per kilowatt as a tariff. Now, the smartest way to do it is while we since our platform already cuts across, it onboards all the energy through smart meters. We have already also onboarded chargers. We know what is the charger capacity, how much of use the charger is currently being used, and which vehicle is being charged. We have also mapped the vehicle to which schedules in the morning or as per the tender, which schedules they are supposed to go out. Since we have all the static inputs and we know dynamically how much of load is being used throughout the day, uh, and we take input of the tariff of that particular location. Now, in this case, I'll talk about Telangana. We do smart charging and dual gun charging at the night to maximize the 15 and 20% electricity incentive, which the which any particular operator can incentivize on, while it's a win situation for the utility because that is what the adoption they want from these depot. Now, for the demand flexibility, why e-buses are one of the much easier component to do so is because the operations is always scheduled. So, and there is a crux to it, and that is only if we have all the data points that is from the vehicle to all the way to the grid we have digitized. That is the only way we can shift the load to later in the evenings or any duration in which there is incentivizing happening to the operator, while there is the incentive which is already planned by utility to give it to. This adoption can only be driven if there is smart systems in place at the depot level, at the vehicle level and charger level uh, across India. So at Kazam, that is what we are doing. We call this EV depot management system, where through telematics we're connecting and getting dynamic data of the vehicle through our OCPP based CPMS solution. We onboard the chargers, and we smartly modulate. We smartly say when to start and stop charging remotely. And through our energy management and smart meter onboarding, we have better control on what is the load that is available as per the sanction, and how much guarantee we can give to the utility that we can shift X percentage of load towards the evening or the time zones where it is required by the utility to shift. So I'll just briefly take you through the form. So like I said, the buses are also something we have connected. This is a digital twin. This is merely for a demo, but the platform is more technical. The chargers are connected to the platform, and like I said, the smart meters are also connected. So we get all the data points all the way from HT, which is right after the discom meter, to the input of the charger. So this also helps us which particular chargers are currently being utilized a lot. And the other incentive which we give to the operator, which is the bus, is also standardizing the SLA, which they have signed with chargers and transformers. So my whole presentation, or what I'm trying to say is, while we are focusing on shifting the demand and helping the utility better make the grid reactive, it is very important to incentivize the end operator, in this case, EV bus operators. So we have derived multiple levers through which we can make this more, incentivized for operator or bus operators perspective. I'll just take you back. So basically, by installing smart meters at each and every endpoint, you can, as you know, we cannot touch any of the meters that is installed or commissioned by the government. But anything after the transformer, government, there's the private players' job. They can choose to install the smart meters and commissioning. It comes with a cost, and that's why we are working with OEMs, where we help them and consult them on why installing smart meters are very important right at the planning of the depot phase itself during the civil works. So the per kilometer GCC model, which you were mentioning, when it comes where electricity is also the part which needs to be considered during the operation. What happens is, when the tenure goes about 10-15 years, during third or fourth year of the tenure, the lot of assets in the depot or any bigger hub start to deteriorate because they are not being maintained as per the SOP, which is committed by the vendor. So this is one of the incentives which we are deriving for the operator. Now we are working with also some of the utility players so that we can create a win-win situation, which I was mentioning, for the utility or the discom at the geography, and also the operator of the buses who are running hundreds of buses there from one particular depot in B2G and also in B2C scenarios. So one of the insights that we also understood is that the decision of charging which bus when is still haphazard, as in it is very reactive. It is that decision is not taken on basis of how much of electricity the operator is saving. That decision is not taken based on what utility is demanding from that depot. That decision is not taken basis of how long I can last my battery, because that is also one of a big lever. for the operators because they want to keep running these buses at the best condition as much as possible. So connecting vehicle chargers and energy through smart meters becomes very important as we are now growing more and more EV buses on road as we speak, which I think everyone would be knowing. So this is all I wanted to talk about. Hope this was helpful to give a insight. And I will stop sharing my screen.
Thank you. Thank you so much, Akshay. Yashraj, with your permission, should I start with the panel deliberations?
Yes. Yeah,
That
please.
Okay, great. Thank you so much. Thanks, Yashraj. Thanks, Akshay, for making the sort of making our lives very easy in the panel discussion because you have covered quite a few intricacies of managed EV charging and the role of demand flexibility. Firstly, a big shout out for our fellow panelists here. Akshay, Arjun Gupta from RMI, Mr. Manoj Gupta from GBM Group, Pradeep Aggarwal ji from BRPL, and our close friend Rahul Lamba from the energy company for having joined this webinar and accepting our invitation. I think we sort of started with understanding the need for creating some flexibility in the managed EV charging, given the grid perspective. And the grid perspective was basically an aspiration to have more and more renewables sort of integrated. And at the same time, from a distribution licenses perspective, it's important to manage the grid itself, right? So you have to get the electrons flowing all through. So in that context, we have actually curated some questions for our friends here. We'll run through some of those questions, request them to sort of share their thoughts succinctly so that we can ask more questions to them. And at the same time, we will also have a Q&A session towards the end of this session. I'm going to start with Mr. Pradeep Aggarwal ji, because if we are talking about grid interactive bus systems and so on. So I think you become a very important conduit here. So you have basically smaller two-wheeler chargers, which are not even fast chargers, and you have very sort of intense 350 kilowatt loads coming from one particular bus system and so on. So as one of the leading distribution licenses in the country, I would like to hear your perspectives on how the charging stations are actually contributing to the discom and especially the peak demand. So are you facing any challenges on account of the large and small charging infrastructure that is coming up? Does it give you sleepless nights, if at all? Right. So over to you, Pradeep ji. Thank you.
Yeah. Good afternoon. Thank you, sir, for providing the opportunity. Am I audible, sir? Yeah. Sir, EV is a good opportunity. EV load being a good opportunity for a discom, but the peculiarity of being coinciding with the discom peak gives us a little pain in managing the EV load. At present, in BRPL area, we have approx 85 plus megawatt of EV load, which is being served to DT to all kind of EVs being plying in our area. 50% of this load is pertaining to DTC, the electric bus charging. So almost we have 45 plus megawatt being energized for DTC depot and gone to e-bus charging. What happens is in the night and in the afternoon, we have two peaks. What happens, the EV load is gradually start rising when discom's peak is also coming up. So 10 to 1 in the night, what we are seeing is that both the peaks coincide each other, the discom peak and on top of it EV peak. So we have a difficulty in terms of managing that time, the energy and the network. So our submission as a discom to the charging operators or DTC depot operators is that if you can manage from your schedule and leave spare some kind of capacity and optimize the charging during those times. That will be very helpful for a discom as such, and also helpful to the e-bus operators or other EV charging operators in terms of getting concessional electricity, because in during peak times we are leaving 20% of surcharge. However, in the off-peak times we are providing a 20% of a rebate. So that's effectively you will have a lot of bandwidth in terms of 1 rupee 60 paisa to 80 paisa per unit of charging in case you shift your peak charging to other time slots, that is normal or off peak. When I say off peak, peak and normal, these are being categorized in terms of load. The heavy load hours we called it as peak load, which for BRPL it is from 2 to 5 in the afternoon and 10 to 1 in the late evening to night hours. And when we say off peak hours, it is 4 to 10 in the morning, 4 a.m. to 10 a.m. and remaining hours are normal hours. So that is what our submission is. And we are projecting EV load by 2030 to be 500 megawatt for Delhi as such, and most probably being DTC kind of contributing 50% of to that load. So that will be almost 7 to 8% of our total load which we are catering to the consumers of Delhi.
Thank you, Pradeep. I think that was very well put. You shared very important numbers as 500 megawatt by 2030, and I'm sure as a grid manager, you certainly would be worried. There are several nuances that you talked about, which is to make sure that the bus charging is not coincidental with the system peak that you are experiencing. And I think that now leads me to learn, a desire to learn from Mr. Manoj Gupta from JBM Group, because you are the operator. You have certain operational constraints. So as much as a distribution licensee would not like you to charge during the night time, perhaps that's the only time when you can charge. So I would like to sort of understand some nuances from your perspective as to what are the constraints that you're facing in terms of charging? Are you contributing to the peak? Are there any different experiments that you are planning in order to shift the on-peak duration charging to off-peak duration charging? So I would like to learn from you, what are the operational constraints that you face as an operator of a EV bus fleet? Manoj, please. Thank you.
Thank you, Mehdi, and really appreciate and systems in terms of organizing this whole discussions in a very sequential and very rightful way. So firstly, I need to set the context from a depot operation point of view before we connect with the DISCOM directly. Because so far you have understood in terms of DISCOM side of this demand flexibility and from say Kazam in terms of monitoring. But we need to understand kind of a fundamental how depot operate. What are the planning when you develop a depot, right? That is where we as a Ecofuel EV charging technologies, we are working since 2018. And today we have developed more than 40 depots across 10 states. So there are various experiences and various learnings in terms of planning. So most important thing we need to understand from a bus operation point of view. Here we are all talking about incentives, disincentives, penalty from a DISCOM as a just one resources. How as a generating or a distribution resource, they are providing service to us. But fundamentally, we need to understand as a e-bus, it is also a public subject with a social obligation to operate the services in a defined routes. Okay. So when we talk about a depot, its particular location, and from that location, the number of routes which being taken through that particular location. Secondly, fleet size in that particular depot. So these are the output in terms of depot operation. To ensure this particular depot output, which is a subject as an alignment through our alignment in terms of state transport undertaking, then the contractual obligation in terms of fulfilling our obligations towards the tenders, and then start doing a ground zero work in terms of our planning. Okay, what is the capacity to be deployed? What is the load we need as a sanction? And then how at a peak load, various situations are going to happen. So when we think through these things, the fundamental, goal in terms of our HT connection and our LT deployment planning and our charger capacity and the number of chargers. So here we are talking about at any time of the day, how it can be, used for a particular, demand, or it can be charged. So we need to understand it start from this particular aspect in terms of planning for the number of chargers and creating the parking, and then looking at the frequency of the vehicles which are coming in at a particular time and going at a particular time. So all those things are a very, very important operational planning. And then there are contractual obligation in terms of time. How particular time duration during the day and during the night, the fleets and the individual buses available for the charging. And that is somewhere we can define now the EV charging at a depot level is not a charging business or a power business. It's about the time management. Everything is a time management and every minute count there. Okay. And as a depot, because we all understand it's like a mini grid. Minimum is a 4 MVA, which is being, required.
Are others able to hear?
151. So this number of fleet when we operate, and then synchronization in terms of making sure the time availability. So here comes the real game plan. The vehicles start coming in the evening from say 7 p.m. onward, 8 p.m., 9 p.m., then up to 12. And then they are there in the depot for 6 hours or sometime 6 and 7 hours. And in the morning again, they start going to the route from 5 a.m. onward. And in the daytime, they again come back to the depot for top-up charging. So ultimately, here we need to understand one aspect. It's not just about how discom peaks for a particular location or for a particular city is being measured. And on a practical note, as of today, all depots of ours are getting a dedicated HT line. So it means whatever being planned day zero when we do the applications. So it means as per discom planning, that depot has been given a dedicated line and it is operated under that. And that gives us two assurance. One, the load planning has been done nicely. Second, there is no power disruption in terms of 24/7 operation, right? And third thing is whatever planning we have done to support a particular fleet, its demand is getting fulfilled in terms of fleet's operation. So here comes few aspect in terms of how to do that demand flexibility, how we can release that kind of a demand. So that is where more than time, because that time of the charging is a route driven subject, and the city, kind of a operation management, which is outside the depot. So, and then the buses are coming to the depot is a second story. So here in our case, we are doing it at 2-3 different level of demand flexibility and ensuring whatever load we have, how, as a peak load, it's not like whatever sanction load and deployed load and peak load. All three are different for us. And that is where we are trying to do a value additions. I'm saying value additions, what it means. At a depot, it is not just for charging. At a depot, buses coming for 3 different things. One, the maintenance of the buses, the cleaning of the buses, washing, and then the charging, and then the driver change the duty. So this is how the current operational practice is. And secondly, in this whole thing, we are trying to optimize in a way that sequentially, whatever be the best timing or in consultation with the discoms is the best time, we put sequence accordingly in various state and in various location. Secondly, it is not just about the power side of it. It is about technology intervention. It is about solution engineering. Now, on one side, we're talking about the demand and the availability. Here we have done last year a new innovation in our product positioning, which is a load sharing. So instead of an isolated charger, we have created a large megawatt charger. And there we put dispenser-based solutions, wherein, let's say in isolation, I be using 3 chargers. Here I have put 6 dispensers. So if we understand e-mobility, the charging behavior, the charging profile, it never is a linear. It go with the start peak, then straight, and then go down. So it means in the night when we do, it's a slow charging, and in the daytime, it's the optimum peak charging. So this particular aspect had prompted us to innovate a solution whereby whatever be the availability of the or sanction or deployed load we have, how we can add more vehicle even, so that that particular power which is available but which is not being utilized. So what happened is the 3 dispenser give full power to the 3 buses, and 3 buses remain attached to the another 3 dispenser. And during the as per the charging profile, whenever there is a units available, it is getting loaded in that bus. So it means the first peak time, which take longer time duration, we are getting it through this dynamic load sharing principle, which is very, very uniquely, being taken up as an initiative. And rather than we are saying that the whole buses are charging at 1C charging rate, this as a slow charging is helping us on getting the equipment, the battery life, the time, the bus getting few units in terms of peak time. So rather than adding more charger and more, stuff or the more power demand, we are optimizing that. And third, most important stuff which we are gaining over here is, if we are doing in isolation, like the individual bus, individual charger, once the charging over, we need to remove the bus, then we need to add the bus. It is wasting my 10 minutes. And at the most efficient way, we are bringing that efficiency from 10 to 6 minutes also. But per bus, 6 minutes multiplied by 150, you can imagine how much time loss we are just doing. And for that time, the power is available. Right. So that is how we have optimized that thing also to enhance our efficiency of the operation. So with this whole aspect, you can imagine when we operate the depot along with our load side, discom side aspect, we take care of operation fulfillment with the technology intervention and with the business model intervention, and then we can say yes, we are optimally utilizing the resources in a proper utilization way. And today, just as a final point, we are operating the depots. That is what the planning means. More than 50% in a day, means in a 24-hour cycle, 12-hour plus our depots are fully loaded. So still I have 12 hours available, which can be further I can use for another EV segment and or more fleets during that off peak in terms of my fleet operation. I hope I'm able to address.
Yes, yes. So actually, Manoj, I must express here that so many myths about EV bus charging, constraints that people keep talking about. But I think you really brought in a very pragmatic and practical approach, and the nuances related to the operators from the operators' perspective. I think thank you very much. We have lots of questions for you. We'll come back to you, but now let's move forward. I'm going to request Arjun from RMI to give a little bit of a sort of broader picture. What's happening at the national level? You guys are working across different states, and then you also have been behind some of the new policies that we saw in the space of e-buses and so on, with the aggregation from CESL and so on and so forth. I would like to understand from you, when e-bus procurement is planned, are there any sort of nuances related to the grid management being brought into that procurement process or the entire management process? And what are the new sort of policy imperatives that we are seeing in the e-bus procurement and associated grid impacts? So, Arjun, over to you. Thank you.
Sure, Malaysia. This is a really wonderful panel. So much to learn already, and thank you for getting me. So let's talk about this. Hello, hi. You guys hear me?
Arjun, your voice is a bit patchy.
Hello. Let me try turning off my video. Maybe there's a connection issue on my end. Am I audible now?
Yes, you are.
Yes. Okay, perfect. So I was just saying that let me give you some perspectives on what really is sector looking like today and going forward. So I think today we are sitting on about 10,000 e-buses that are operating in about 20 cities in India. And if you look at the latest e-drive scheme, I think there was a request, a target of about 14,000 e-buses as per the scheme, and the center has received requests for 15,000 buses already. And we are projecting to hit about 17,000. I can clearly see that there's a lot of movement happening in this space, and growth is tremendous in terms of e-bus deployment as well. Now, the implication of this growth is obviously significant for the overall transport sector, but obviously a large impact is also on the power sector as well. As Pradeep ji was mentioning a couple of minutes ago, that the impact for BRPL is that they have about 500 megawatts of peak demand because of buses by 2030. We actually did a study with them last year on what really is overall the impact of this on the grid. And as he rightly pointed out, the problem is that this demand is coming at the same time that Delhi especially has a peak on in the summers, which is in the late evenings around 8 to 9 p.m. till about 12 a.m. And what happens is that these buses are also sort of being charged around the Hello, hi. Sorry, I think my internet conked out.
Yeah.
Audible?
Yes, now you are, Arjun. Go ahead.
Yeah, sorry about that. Sorry about that. I was saying that we're looking at about 400 to 5 megawatts of peak demand just in Delhi, which is about 4% of Delhi's peak demand. And going beyond e-buses also, other large sector that we don't talk about much is the commercial EVs segment as well. Delhi is aggressively adding commercial EVs as well as per their EV policy. And we are about 5% of Delhi's peak could be just because of EVs and e-buses by the end of this decade. And going pan-India as well, right? Like our team was running some numbers.
Yeah, Arjun.
Let me do this. Yeah, let me fix my internet
Right.
while you guys can jump onto the next panelist. Sorry about that. Yeah, I'll just fix my Wi-Fi.
Now it's time to sort of, and I think Arjun made very important points, like the big picture of 17,000 e-buses coming in, and we're talking about 4% of the Delhi's peak demand coming from e-buses in 2030, contributing around 500 megawatts, and so very interesting data points. Now, as much as we sort of discuss some of these large numbers with e-buses and so on, I think it's important for us to not neglect the two-wheelers and three-wheelers and passenger vehicles that are getting sort of converted to EVs. So our friend here from the energy company, Rahul, has been doing remarkable work in the space of battery management itself, making sure that the batteries, the longevity of the battery is sort of ensured by way of different cell level modulations, and at the same time thermal management of the battery casing itself. So they have done some remarkable work. I think they started with two-wheelers. But Rahul, I would like to sort of understand from your perspective. When we look at two-wheelers market, what comes to our mind is also the opportunity for swapping stations.
Yeah.
And the swapping stations from the grid management perspective are nothing else but somewhat of a battery energy storage system, which is behind the meter or in front of the meter.
Yeah.
So the way this space is evolving, the way the two-wheelers are evolving, the EV two-wheelers are evolving, at the same time, battery technologies are evolving. From your perspective, can you please sort of highlight what are we going to see in the coming few years? What is the role of two-wheelers contributing to the peak, or in fact coming to the rescue of the grid if you have some kind of an interim battery swapping stations also developed? And also would request you to reflect on the afterlife of the batteries. Is there any sort of a second life which could be useful for the grid itself? So over to you, Rahul. Thank you.
Hi, everyone. Firstly, thanks, Meshi and the team for inviting us to the panel. So from our perspective, I'll tell you like what we have been able to do in the two-wheeler market is something that we believe is highly scalable and is also beneficial for e-buses. So in fact, in one of the pilots at our facility, we have been able to schedule electric two-wheeler charging as per the electricity pricing differential. And interestingly, this is controlled through an application. What we believe would actually become a game changer if we are able to deploy it at a wider scale with multiple vehicles and for vehicles which have larger batteries, specifically e-buses being one example. So as Kazam team had also mentioned that this will definitely have an impact on making sure that the peaks are getting offsetted. But on the other side, the other big advantage of tweaking the charging behavior, reducing the peak current demand because there's a longer time tenure available, is the impact on extra battery life that the end customer can retain out of it. So in fact, based on our assessments, we believe that by doing smart charging, which we can actually optimize the battery and extend the life by another 10%. So imagine that for an e-bus, where the asset cost itself is like a 40 lakh rupee, approximately, say, for a battery pack, you can imagine that we are giving a customer advantage which is worth 4 lakh rupees over a tenure of say 8 to 10 years. So this is one of the leverage that we are trying to work upon, and we believe it is scalable to different markets and segments. But coming on to the other aspect of specifically older two-wheeler batteries on what they can contribute in. So there, I believe like multiple of these packs, like hundreds to thousands of these packs can be clubbed together. Older packs once they get retired from an automotive use case, and then they can be used as a power backup system. So because the whole idea is that we want to reduce the peak, which is like the peak is becoming more and more steeper. And the whole idea of why everyone is trying to deliberate is we know that problem exists, but what are the alternatives? One alternative, as the panelists mentioned, and even I was talking about, is smarter charging. But the other one is a large co-located storage, which can make sure that during off-peak hours, we can store the excess energy inside a large battery bank, which could be consisting of, say, hundreds to thousands of smaller two-wheeler packs, or it could also like be developed using say 50 to 100 of old electric bus battery packs. Yeah, so these are like the two ideas, but specifically on the co-located storage part, if you ask me, I would say India is very early in that journey, and there are like the price arbitrage between off-peak and on-peak hours. In fact, if the more widen that difference becomes, the better business model viability will come for a co-located storage.
Great, thanks, Rahul. We'll come back to you with more questions. But Arjun, would you like to sort of complete your intervention as well?
Yeah, sure. Thank you, Mahesh. I think I was just closing out my one thought, which was about what it really means for an all India number as well in terms of the growth in the sector and what it means for India's power sector as well. If you are assuming that you want to have an Atmanirbhar Bharat by 2047, our numbers suggest that we require about 6 lakh plus e-buses by 2030. and that's about 6 to 7% of India's peak demand. So we are looking at a very interesting sector, which can either be a challenge because meeting 6 to 7 additional peak demand for India, especially at a time when peak demand management is already a challenge, will be problematic. But at the same time, if managed well, this is a resource for the power sector to utilize as and when demand flexibility as a resource picks up. And like we already discussed many times before, this is one of the lowest hanging fruits for demand flexibility as well. MOP does encourage smart charging and charging to respond to demand response, but there isn't really any mandate or any program that exists by the center to really make managed charging a reality.
Great, thanks, Arjun. I think this was very useful. I would now like to sort of pose one question each to the panelists before we open the floor for Q&A. Let me start with Akshay ji from Kazam. So you presented a very sort of interesting what if and very tech-driven intervention with smart meters installations as well as a lot of back-end support that you saw. You have been doing some experiments with a few distribution licenses, I think with BESCOM, etc. as well. So, what is the problem statement that you are hearing from the participating distribution licenses? What is the problem that you're solving as Kazam that is posed to you by the distribution licenses? So, some reflections on that, please.
It's on the same lines that we were discussing so far. I think most of the panelists kind of touched upon it. It's about the demand flexibility or a guarantee that we can give back to the distribution or the discoms, that we can guarantee that this many amount of usage of energy, we can shift it to a different time frame, and we have that control over the load. And that control over the load of shifting it comes with the know-how or the knowledge of the bus operator or the bigger hubs, and through the connectivity piece that we have of the vehicle. So while the discom wants the flexibility, they also want a guarantee, can you do it, so that they can take the decision on reactive basis, which is when can I afford to shed the load from one particular depot or multiple, like that you can imagine hundreds of depots, so that a more critical infrastructure, let's say hospitals or any other where the load shedding they can avoid. So you might have seen in Bangalore random load shedding keep on happening. Those kind of decisions actually, those kind of shedding, what we understood from them happens because they actually have no visibility on when suddenly there would be peak in demand. But in cases of buses, because we know these are scheduled and we have that data from vehicle level, there can be a model which we were piloting with BESCOM, is what I was saying, where we guarantee them, hey, we can shift X number of buses to a non-peak area, which will give you a guarantee of, let's say, even close to megawatt of load, which you can use maybe somewhere else and better plan your generation and redirecting the same load to somewhere else.
Thank you. Thanks, Akshay. I would like to now request Manoj ji to reflect a little bit more on the intercity transit, which is again getting shifted on EVs. So far we have discussed sort of depot-based charging, which is intracity. So any thoughts from your side when we look at, say, Delhi to Chandigarh or Mumbai to Pune? Some of those corridors also have a lot of EVs now flying and EV buses now flying. So are you seeing any kind of newer opportunities there in terms of managed charging in that space, Manoj ji?
Yes. So intercity, is the very, very important aspect of this whole electrification. If we see depot charging in the intracity, it's just a starting. But overall, if we see the transportation mobility, not only just the electric buses, but the upcoming logistic from a e-truck and other, aspect. So EV charging or kind of electrifying highways are very, very important. But when we talk about highway, it comes with a lot of its own challenges. That is where a lot of intervention from the Ministry of Power, DISCOM, and the various states are involved. Because here the challenges are much, much higher than what we have in the city itself. First, the highway is not belongs to one state, the multiple states. Second, the connectivity of the grid availability is a huge challenge in terms of identifying a proper location and then getting that particular load and kind of availability there. Third, the highways are having a particular kind of a length on which a particular vehicle with a specific battery capacity. So it means it becomes like a very, very sensitive subject. What could be the location point to serve individual vehicles? Because some vehicle may go with a 100-kilometer range, or some may 200-kilometer range, or 500-kilometer range. And then most sensitive point over here is the vehicles are carrying the people, the passenger with them. And that another kind of a inconvenience if we think for for large or long duration stoppage there, for the convenience for the people, and then most important the safety. Because here what we have observed is ki, as a practice in depots, even we don't allow the driver or any individual to sit in the bus when we charge. Very, very sensitive thing, right? So the same thing we expect when the charging happen even the outside. For that matter, any vehicle, it is an advisable practice. One should not be there with the vehicle when the charging happening. So these things are creating a bit of kind of a both challenge and an opportunity, and that is where we see in our whole feasibility the renewables have a lot much to play in terms of energizing these highways more than the grid. If the renewable sector along with the battery energy storage system, because these are the best in terms of creating that flexibility in terms of planning, the designing in terms of the location for readiness of such aspect, and then coordinated efforts from the Ministry of Power and NHAI. How based on the demand availability through DPR, if they can do through various states and particular locations. So rather than waiting for some charging operator to come there or someone coming for this, here what we are looking for actually as an intervention or advocacy, the the discoms need to proactively work and create a dashboard kind of a thing. At which point the power can be facilitated, and this is the time duration in terms of activation, because it's all about GTM. The operator take huge time to start their operation. That is again a long time, and second to get charging operation start another long queue. So overall motivation for enhancing that particular thing, which is a very, very opportunity area for a large adaptation. And very happy to share here ki even at JBN we have taken one very, very important initiative in terms of shifting our buses, the manufacturing from the manufacturing plant in Banchari in Haryana to rest of the depots. Instead of sending it on through trailer, what we are doing is we are aggregating CPO's available capacity for charging, even if 60 kilometer, if the standard is CCS2. So our drivers are being trained, so they are taking the buses by route, by road itself. So this is a big change, and that we are doing it to demonstrate end-to-end operation management, where even from this starting point, and by doing this, we are trying to serve two purposes. The vehicle, when they cover these like 1,000+ kilometers, so that shows their readiness for with the best of the product and the life. And second, on the way, so many CPOs have invested heavily, but getting demand is their challenge, which through our intervention as a Ecofuel, we are aggregating those demands and giving them that flexibility of utilizing it. So with this, yes, long way to go, but good opportunity, but a lot of collaborative efforts. It cannot be done with one individual or one company. So more we will collaborate, more we will create, co-create. And including this thing, another solution which has been added is the mobile charging. Because to address the anxiety in terms of even these are fixed locations. So how if something happen on the way, what to do? So that is where we are working out some mobile charging solutions. Again, with the particular aspect of positioning them, we are calling them charging on the wheel cow. So that to some extent of, let's say, 20 kilometer left, 20 kilometer right, they can cover some, best range. Okay, at least in need of such crisis, because in 24/7 operation, you never know when the criticality happens. So these flexibility are important. Thank you.
Thank you, Manoj. I think very well put that it's like collaborative effort and a lot of co-learning. I'm going to now request Rahul ji and Pradeep ji to answer one question in 60 seconds each. So let me start with Rahul ji. So you have different types of battery suppliers, unorganized and organized, right? So are you seeing from the grid perspective, demand flexibility is one part, but are you seeing any kind of power quality issues emanating from the charging process, especially for two-wheelers, three-wheelers, and the auto rickshaws that we see in some of the tourist places and so on? So 60 seconds to you, please, Rahulji. Thank you.
We are actually not seeing a lot of challenges on the battery side, because generally what happens is the charger makes sure that any fluctuations from the grid, it is compensating for it and making sure that we get a decent power quality for charging these battery packs. And if it's beyond a certain level, then the charger is not even like, it's not even operating. So, but these instances have been like, if I have to give a number like less than half, like even half a percent.
Okay. Great. Thank you. Thanks, Rahulji. So, Pradeep ji, a similar question to you. Plus, I'm going to add to that question. You have been sort of doing a lot of tariff innovations, including time of day tariffs and so on. So, any special thinking about EVs as a sector, and how is BRPL or several other discoms in the country thinking about creating newer tariff structures that would enable more flexibility? Pradeep ji.
Yeah. First of all, sir, good to know that a lot of operators, like Manoj sir said, they are doing a lot of efforts in terms of optimizing the load, charging, slow charging during peak hours. They are also aligning operations as per the grid requirement. That is very good initiative, in fact, taken by the depot operators, and that will help us adding a lot of flexibility in terms of demand management during peak hours. As such, at present, we have 7 depots in operation in BRPL area, and we found that this flexibility is yet to be seen by adopting these best practices. But yes, congratulate by enlighten all of us by doing so many good initiatives in optimizing the load. In terms of tariff is rationalizing, yes, what we are expecting a regulator to compensate us as a discom in terms of tariff, because what right now we are doing is we are subsidizing around 1 rupees 50 paisa per unit of EV charging, and we are putting a burden on other ratepayers. For every consumption of every unit which is being consumed by the EV user, we are kind of providing a cross subsidy burden of 1 rupees 50 paisa. So we are expecting that this has to be taken care of by the regulator. Number two, we are also expecting, yes, in the time of need, the EV user can demand the electricity, but they have to pay the premium as per the MOP guidelines, which is 1.3 times. So yeah, you can demand, you can use the resources, but in times of crisis, in times of peak, you have to pay the premium. So for that, you have to compensate the other party as well. And in the off-peak, we also expect their kind of further reduction or further reduction in the tariff structure to create kind of behavioral shift and the motivation to the EV users.
Great.
One more question. In terms of harmonics, there is a lot of DER which is already being comed up in our area. 160 megawatt of solar, 80 megawatt of bus charging, and we found technically there are a lot of checks and balances already put in place in the charger, in the battery energy BMS level, where negative harmonics, negative power, over injection of reactive power is being taken care of. So that is, I think, not a big challenge to our company.
Thank
Yeah,
you.
over to you, sir.
Yeah, thank you, Pradeep. So I have one question to Arjun, and then we have a couple of interesting questions in the Q&A. So we leave 5 to 7 minutes for that before we wrap up. So Arjun, from your perspective, RMI works globally as well. So can you sort of cite one or two global best practices in managed EV charging for passenger vehicles at the same time for the e-buses? Arjun.
Sure, Mahesh. I think thank you for that question. And I think there's a lot happening globally speaking, and that's actually what has inspired us to work in this domain. If you talk about, like you said, there are two different types of programs. One is for e-buses, and some examples come from California, where PG&E uses time of use pricing, demand response signals, and smart chargers, where they've been able to reduce the peak demand by about 40% during the peak hours of 4 to 9 p.m., which happens there. Similar examples are also there in the Netherlands, where they use real-time dynamic load control based on load conditions. London uses depot-based smart charging, which are programmed to charge off-peak during off-peak hours using the software similar to what Akshay demonstrated today as well. And again, it's tremendous savings. In the Netherlands, you're seeing 60% load shifting happening during the high demand response or high demand events. And this is across, like different charger types. You have e-bus chargers. You also have EV chargers where all of these programs are run. One very interesting program that happens primarily for private EV chargers, home chargers, etc., is in California, where rebates are provided by the utilities like PG&E and SCE and SDG&E, a discount essentially for consumers who want to buy home chargers is given to them if these chargers are auto-enrolled in DR programs already. What that means is that whenever a DR event happens, these chargers automatically are controlled or managed by the utility to turn off or reduce charging to minimize the stress on the grid. So this is a win-win situation because the consumer gets a cheaper charger, so he saves money, and the DISCOM obviously over time saves enough electricity on the electricity costs by offering these discounts as well. So that also has had a lot of traction in places like California. And very interestingly, I was talking to Tata Power Mumbai a couple of days ago, and they're actually piloting the same program where they are offering free EV chargers to consumers who are interested to put up chargers, with a caveat that you can only charge your EVs from 10 p.m. to 6 a.m. And that's great because for a consumer, most charging happens at home in those hours, and Tata gets to control this charging at a time when there is, a total off-peak period as well. So we are seeing some traction happen in India, but there's a lot that we can learn from geographies outside where EV penetration is going up pretty quickly.
Great. Thanks, Arjun. So we have a few interesting questions. Let me quickly run those by the panelists. So one question is from Chandrakant Kulkarni, which is he asks, depot owners are in a unique spot, meeting their business needs and being in compliance with utility imposed penalties or incentives. Is there a proactive conversation between utilities and depot operators to find a balance that works for both the entities? Manoj, if you can please take no more than 60 seconds because then we can cover more questions. Manoj, please. Thank you.
No single line answer is all depots being developed after due consultation with DISCOM, then the regulatory compliances, and then the depot start operation after CIG approval. Okay, so without this, nothing happens. So it means there is nothing, something say open-ended. So it's a complete closed loop. Yeah.
Thank you, sir. So some interesting questions from Mr. Kandar Mistry. So let me start with the first question for Akshay, where the question is about communication standards infrastructure for talking with grids smartly in real time and smoothly interface with utilities cloud server you are available. So are you seeing any kind of interoperability being created in this system so that more and more solution providers can come into the marketplace?
Correct. So that's where smart meters come in. So most of these smart meters are Modbus enabled. Basically, what does that mean is we deploy IoT edges, which is nothing but a server at the edge, which communicates with the smart meter and actually makes them online. So now we have seen more smart meters that is coming from subsidized form from government, which have network capability inbuilt, which means these smart meters are directly connected to SCADA systems of Discom level. So yes, more and more there is adoption in the communication, and it is, I think, ever going to scale.
Thank you. Thanks, Akshay. So, Rahul, same question to you as well, because you're looking at a cell level communication protocols as well. So, Rahul.
Yeah. Yeah, so like Akshay has actually covered it pretty wide from that side. I'll just mention one more thing which is emerging and coming up, that is UEI. So similar to how we transact with payments, similar way in the government, and there's a couple of organizations. Kazam is also part of that initiative. We are also part of that initiative, where we are trying to create a unified energy interface. We all believe that this is actually going to be a game changer. And this is one large thing that will actually impact and help us all reducing the peak and ensuring that we are able to provide power to everyone at the lowest possible cost.
Great. Thanks, Rahul. So we'll take last question and I'm going to hand it back to Yashraj. So last question is by Shilpi. She's asking, will integrating RE along with battery storage increase the cost of power? So perhaps, Arjun, you can take this.
Yeah, I think it's a question which has both answers, yes and no, because what's happening is that there are some states where the electricity tariff is for EVs is subsidized, and it's hence challenging to compete with an RE plus battery storage tariff with those e-bus tariffs that are provided. Now, if those e-bus tariffs are not subsidized, I think RE plus BESS tariffs have a very good chance of competing with the grid tariffs as well. And especially because RE plus BESS tariffs are locked in for 20, 25 years by PPAs. So any e-bus operator then has this sort of de-risking happening that for 20 years there won't be any escalation to their electricity costs, while at the same time, they are protected from any tariff hikes in the imposed by discoms.
Thanks, Arjun. I have to take the first question. He was asked in the chat box by Mr. Vijay J. He's asking how battery storage solutions can help manage demand flexibility and provide sustainable power availability. Perhaps BRPL, Pradeep ji can take this question because you, I think, recently launched a battery energy storage system at a grid level as well. So 60 seconds to you as well. Thank you.
Yeah, battery solutions provide a lot of flexibility to us in times of managing the peak. And as we all know that the load, as per the load duration curve, the peak happens only 100 to 200 hours in a year. For that particular duration of the time, we don't want to build a network to that level, and we also don't want to tie up the power capacity and don't rely on the short-term power purchase at that moment of time. So hence, yes, battery energy solutions is helping discoms in managing the peak demands and also kind of providing distributed support where it is required in terms of deferring the capex for the network. Thank you.
Thank you, Pradeep ji. So I think Manoj ji, you have something to share as well.
Just to give a very simple answer to this thing, more than grid side, because that is there for peak demand management, it's a good application. Like for depots, we are going to introduce battery energy storage system at our depots. Rather than getting more load as a deployment, now we are working out a hybrid model. As I mentioned earlier, 12 hours only we are using the charging. So rest of the thing power is available. So we will get that demand in the off-peak hour in the battery, and then in our peak load demand, means the fleet demand during the top-up charging, we are going to put it through battery energy. So that is the smart way we are bringing for utilizing by minimizing capex, enhancing our operational efficiency.
I think Manoj ji, you sort of succinctly summed up the entire webinar here, talking about flexibility, shifting the loads, bringing the cost economics, cost efficiency, and technology as well here. Thank you very much. Over to you, Yashraj. Probably you have only a minute before we close. Over to you, Yashraj. Thanks.
Yeah, thank you. So thank you so much all. I would like all of our panelists, thank you so much for a valuable insight and to our audience for your thoughtful questions. So today's session has highlighted the critical role that managed EV charging can play in enabling demand flexibility. So not just as a response mechanism, but as a strategic tool to shape a more resilient and effective power system. So yeah, and special thanks to Dr. Mahesh Patilkar for steering the discussion so effectively, and to our or to our team for making this event possible. Yeah, thank you so much all.
Thank you very much, everyone. We'll stay tuned in this space. Thank you.
Thanks a lot.
Thank you, sir.
Thank you all.